Here's some examples of sine inverses, well, inverses mixed in with regular trigonometric functions. So in this case, we're taking the sine inverse of sine of 3 pi over 4. And the common mistake is thinking that sine inverse and sine just cancel each other out and you're left with the answer of 3 pi over 4. The problem with that is if we go into a coordinate system and we look at where sine inverse is defined, sine inverse is only defined in the first and the fourth quadrants. And 3 pi over 4 is way over here in the second quadrant. So it can't be the answer of 3 pi over 4 because sine inverse is only going to work in the first and the fourth quadrants. So what we have to figure out is, if we're at 3 pi over 4, what kind of answer is sine going to give us? Is it going to be positive or is it going to be negative? So if we plug in our all students take calculus, we're going to find out that sine in this quadrant is positive. So that forces it to be a first quadrant angle. And to be a first quadrant angle, reference to 3 pi over 4, that's just going to give us an answer of pi over 4. So you just have to be really, really careful with the sine inverses, and it only works in two quadrants, first and fourth. Similarly, we have cosine inverse of sine of 5 pi over 4. So again, 5 pi over 4 is in the third quadrant. If we put an angle in the third quadrant, what we'll find is all students take. The only thing that's positive down here is tangent. So this is going to give me a negative ratio. And cosine inverse is only going to work in the first and the second quadrants. So to be negative, the angle has to be in the second quadrant. So let's throw this angle into the second quadrant. And the reference angle of 5 pi over 4 is pi over 4. So this angle in here is pi over 4. And again, we don't want just the reference angle, we want the angle opening up from the initial side. So this whole thing, and that would be 3 pi over 4. So the answer to this one is 3 pi over 4. Cosine inverse of sine of 5 pi over 4 is 3 pi over 4. Alright, if we just have a reverse situation where we have the regular function on the outside and the inverse function on the inside, this is saying that sine inverse of 2/3 is going to give me an angle, and then I want to take that angle and find its tangent. Technically, we don't need to know what the angle is. Basically, what we're going to do is use the information on the inside to draw a picture, and then evaluate tangent from that picture. So let's start off with a little coordinate axis. And sine inverse, or sine is positive in two quadrants, the second and the first, but sine inverse is only defined in the first and the fourth. So to be positive, it has to be a first quadrant angle. So I'll put a reference triangle in the first quadrant. And then label the sides appropriately to this ratio. Since the ratio is 2 over 3, and sine is normally, well, it is opposite over hypotenuse, the 2 is going to have to go here, the 3 is going to have to go there. And we need to find this third side because tangent is going to require it. So this is our angle theta, and that's all of this stuff here, the sine inverse of 2/3. Alright, to find the third side, we're going to use Pythagorean theorem. So it'll be 3 squared minus 2 squared, and then the square root of that answer. So it'll be 9 minus 4, which is 5. So the third side is going to be the square root of 5. And then just to find the tangent of this angle, it's going to equal opposite over adjacent, so 2 over square root of 5. Let me get rid of that. So this whole thing is equal to 2 over the square root of. We can also do that same technique with just a variable, or a variable mixed with a number like x over 2. But the picture doesn't really change that much. We're still going to draw a coordinate system. We're going to make the assumption that x is a positive ratio, so we're going to just put everything in the first quadrant. And you can play around with it, and the answer comes out exactly the same if you make it negative. So we're going to put our a little reference triangle in here. And we're going to label it according to the sine inverse of x. So sine inverse, sine is opposite over hypotenuse, and we can write this as x over 1. So this would be opposite, but this is our angle theta, which would be sine inverse. The opposite would be x, the hypotenuse would be 1, and we'd need to find the third side. So we could use Pythagorean theorem, c squared equals a squared plus b squared. And in this case, c is 1. 1 squared is 1. We can let a be the x squared. And then what we're looking for is that third side. So this becomes 1 minus x squared is equal to b squared. And then solve it, we're going to square root both sides. So this third side is going to be the square root of 1 minus x squared. Now all we have to do is find the cotangent of this angle. Well, I'm not cotangent, cosine. And cosine is adjacent over hypotenuse. This whole thing is going to equal the square root of 1 minus x squared over 1, or just the square root of 1 minus x squared. These are real powerful in calculus when you get there.